আচ্ছা, সো লাইক মোর ইম্পর্টেন্টলি যখনই আমরা ফোরিয়ার সিরিজ করছি বা এনিথিং উই আর ডুইং উইথ ম্যাথমেটিক্যাল ফিজিক্স, it's very important that we are more or less comfortable with the formula. So basic formulas are clear, like these things we already know. So if we talk about these formula like linearity and all, how to integrate, we already know these things. Integration by parts, you can integrate one and leave the other one aside, so these things are simple. It's not a big deal. We know how to do definite integral, that is also not a problem. Sine ax dx এরকম ইকুয়েশন অনেকবার আসবে। সাইনের ইন্টিগ্রেশন হলে মাইনাস হবে 1/a cos ax plus c. If there is no definite limits, we have to put a plus c there, that's again important. uh, Something which might be interesting would be these kind of formulas that you need to remember, because what happens is many a times you don't get time to actually solve it, so it's better to remember these actually comes under standard formula. এখন যখন ফিউচারে গিয়ে we are going to talk about gamma functions and all, there will be a lot of relations where you are going to use the formula directly. You are not going to solve it because you won't be having that much of time. The numericals are usually longer in nature. So x sine ax dx, I'll share this with you. If you integrate it, obviously you have to integrate it by parts, by uv method, but we are directly writing down the result, and it is always preferable that for such kind of equation you remember the result. Sine ax by a square minus x cos ax divided by a, আর x cos ax হবে cos ax by a square plus x sin ax divided by a. So এখানে sin এর জায়গায় cos, এখানে cos এর জায়গায় sin, and there is a plus in place of minus. So if you remember it this way, this will help. Apart from that, some identities are also very important, like integral of products of sine and cosine. So let's say I am multiplying a sine term with another sine term, okay, then for such case we have to actually use this identity so that we are able to solve it, otherwise it will be difficult. So sine a sine b can be written as half of cos of a minus b minus cos of a plus b. So this is one more relation. Then we have got cos. So তার মানে আমরা এটা মনে রাখতে হবে, what is cos a into cos b, again it is 1/2 cos of a minus b plus cos of a plus b. So when it is sine both are cos, when it is cos both are cos. Sine এখানে একটা মাইনাস সাইন আছে আর cos এখানে একটা প্লাস সাইন আছে. So this is a relation that again we should remember. Here again one more, sin mx আর sin cos যদি হয় তাহলে sin a cos b is equal to sin, okay, sin a cos b যদি দুটো মিক্স হয় তাহলে both should be sin, one is a minus and one is a plus divided by 2. So this is also there. Now one more thing would be if m is not equal to n, okay, and you are talking about m is equal to n, this is the orthogonal property, we have already seen it before. Then many a times this sine will get simplified to sine square ax, and cos will get simplified to cos square ax dx and so on. So it depends on what is the condition that is being given, okay. So যখন not equal to থাকে তখন এরকম expand করতে হবে, আর যখন equal থাকবে then obviously both are going to be equal, and then we can use the cos 2 theta formula, that is it. So this is I'm not discussing, this is like okay, you can do it also, এটা করে নেওয়াটাই better, এত কিছু মনে রাখা possible না, so it's better to do this one also you can do, not needed, okay. Let me come to this, which is more important in Fourier series analysis. For example, if there is an even function, that means we have discussed in the last class also, f of minus x is fx. So for example, if I say f of x is equal to x square, then f of minus x would be equal to minus of x whole square. Minus a square means it is going to be the x square again, so it is again x square. তার মানে this is going to be the original function fx. তার মানে fx and f minus x both are equal, so we can say that it's an even function, okay. Odd function exactly opposite, like a odd function example you can consider this as f of x is equal to x, let's say it's just x. Then if you write down f of minus x, it would be nothing but x এর জায়গায় minus x, so that means it is minus of f of x. So that means this is an odd function. So odd function and even function plays a very important role in Fourier series in order to do your sums more easily and fast. তো আমার ধরো লিমিট আছে minus l to plus l fx dx, okay, and we know that this is an even function, fx is an even function. Then what we can do is we can write a 2 in front and change the limit from 0 to l and not from minus l to plus l. Change the limit from 0 to l fx dx. তো এরকম করে আমি ফাংশনকে সলভ করতে পারি, ইট উইল বিকাম মাচ ফাস্টার। এটা এরকম একদম না যে এটা রুল ইউজ করতেই হবে, ইভেন ইফ ইউ ডোন্ট ইউজ দিস রুল ইটস ফাইন, স্টিল ইউ আর গোয়িং টু গেট দ্য রেজাল্ট, বাট দেন ইটস গোয়িং টু বি আ বিট লঙ্গার, better to convert it into this and then do it, so it will be much more easy. Okay, then this is also obvious logic that if we have an even function and we have an odd function and we're multiplying both of them, then it's an odd function, right? For example, there are two functions fx, okay, and gx, and let's say one is an even function, so it may be, let's take the same example, x square, and this is an odd function, this is x. So now if you multiply fx and gx, you are going to getting at something which is x cubed. So this is odd function, তার মানে odd even multiply করলে আমার odd function হচ্ছে. So even if the questions are there and you are confused, you take these simple examples, then you will be able to solve it. Similarly, আমি যদি odd function নেই, as I said, if I take minus l to plus l, this is symmetric, minus l plus l, মানে এটা minus pi plus pi এরকম হতে পারে, fx dx, straight away you write down the answer as 0. You can solve it, you will get 0, but straight away write down 0 because this is an odd function. So we have to just do it because we want to solve, and sometimes the trigonometry becomes so much that you have to take these direct results. So the product of two odd function is even. This one also you have to remember, odd function মানে একটা x থাকলে আরেকটা x থাকলে you multiply both of them, you get x square, so it is an even function. So this is a very important chart or formula that is important. Okay, now how do we use this in Fourier series? Obviously, if fx is even, then all bn terms should be 0. So the Fourier series is a cosine series because bn term is basically related with the sine one. Okay, let's just let me just go back to the things that we have done before. So if we check our first lecture, here we've seen, okay, so bn term 0, and you can see that bn is connected with only the sine function, so that means this term will become 0, this is a0 divided by 2, and this is having only the cos term, so that means this will actually become a cosine series. So this one we have to remember, okay, this one we have to recall every time, and then we have to understand that this will become actually a cosine series. So in a similar way, if I'm going to talk about this, okay, shortcut that we are going to use, that every time when it's an even function, okay, the sine function will actually become 0, okay, and all the bn terms will be 0. I can have only the cosine series. On the other hand, if this is an odd function, then a0 will be 0 and an will be 0. It becomes even more easy because তাহলে আমার দুটো টার্ম 0 হয়ে যাচ্ছে. If it is an odd function, this will become 0 and this will also become 0. So I'll be having just a sine function. So this is a sine series. So many a times the question is that you solve the Fourier formula which is actually a sine series. So straight away they're giving you a hint. Okay, এর মধ্যে সব cos term 0 হয়ে যাবে আর cosine series বললে মানে sine term will be 0. Okay. So the first thing you have to check for symmetry. It simply means that many a times you have a function like an and cos nx, and a cos nx is even function, and if an is also even, then this entire function is even. But if this is even and an is odd, that means it's going to be an odd function. Okay, so if you talk about in terms of fx, okay, so that is there. So anyway, we're going to look into the formula, that's important. One more thing is this one, okay, these things we are going to use regularly. Sine of n pi is 0, okay, remember this for any integer n, and cos of n pi is always minus 1 to the power n. মানে cos pi is minus 1, cos 2 pi is 1, and so on. Okay, so মানে cos কি হয় যদি it's a multiple, even multiple of pi, it is going to be 1. If it is an odd multiple of pi, it is going to be minus 1. So এর জন্য it's always minus 1 to the power n. You have to just remember this. This is a very important result. Okay, just leave it at cos n pi, you might lose some marks, so you have to use this result. That's important, right? Cos pi minus 1, cos 2 pi 1, cos 3 pi again minus 1, and so on. It goes on. Sin 0 0, cos 0 1, we know it. And then this is also the sine of n pi by 2 cycles through 0 1 0 minus 1 depending on n. So ধরে নাও sin n এর value 0, so it is sin 0, answer is 0. N এর value 1, so it is sine of pi by 2, sin 90 is 1, so it is 1, right? And then sine value 2, it is 2 gets cancelled, sin pi is 0. Then you again take 3 pi divided by 2, and it will be minus 1, and so on. So it keeps on going, again 0 1 and so on, it keeps on repeating. So these are some important trigonometric formulas which should be there, okay, I'll share with you. And based on this we can actually solve a lot of Fourier series. Let's get back to the Fourier series again, and let's take one more example. Whatever we have done till now is good. We can talk about this problem as well. যেখানে we are going to talk about okay, we are going to talk about mod function. Okay, so this is basically a mod function here. So what happens usually is that you know, this is mod of x, so that is important. So this mod of x is even. Okay, we know it is mod of x. So even if you take f of minus x, okay, this is going to be, you know, minus x here, and mod of minus x is going to be again mod of x, even function. So that's the reason that, you know, we can take this as an even function. So if it is an even function, that means your cosine term will appear and the sine term will more or less vanish. Okay, so cosine term would be there and a naught term would be there, right? So if we write it down, we have got a naught, one term, somehow the marker is not working, and then we have got cosine term, and then we have got the sine term. So that's there. So if it is cosine term, then cosine terms is a naught ashbe. If it is sine term, then both these terms will get vanished. So it's an even function, so only cosine term will appear. So we have to just compute, okay, the cosine term and the a naught term. So a naught is 1 by pi. You take the limit from minus pi to plus pi and take the function. Our function is mod of x. Okay, so the function is mod of x dx. So you see, this is minus pi plus pi. This is an even function. Okay, so if this is an even function, okay, if this is an even function, it works. Okay, if this is an even function, then what we can do is we can write down this minus pi to plus pi as 0 to pi, 0 to pi. But if I write down 0 to pi, I can take it in front, which is 2. Okay, so this is an even function. So we have done with this point. So we can just simply take now x dx, and then we can write it down as 2 by pi. x এর integration হচ্ছে তোমার x square by 2 with pi, then pi square by 2. This gets cancelled, 2 gets cancelled, I get just pi. So this is there. Okay, this is simple. So I'll get pi for a naught. And next, the constant term is nothing but a naught by 2. A naught is the constant, so term is a naught by 2, so it is pi by 2. So first term is pi by 2. Okay, for next we have got n, for n greater than equal to 1. Okay, so we can take an. An is again 1 by pi minus pi to plus pi x cos of nx dx. Now cos is an even function. This is also an even function. So if you multiply two even function, you are going to get an even function. So this entire thing is an even function. If entire thing is an even function, again minus pi to plus pi can be written as 2 times of 0 to pi. So again I have written it as 2 times 0 to pi. And then again you can write down it as x cos nx dx. So now you can, you know, integrate it by parts. First function is x, second function is cos nx, and we can do it. Okay, so anyway we are not going to, you know, think about it much, because this is just a simple product rule for integration. So first would be x, and then you integrate this cos nx dx. Cos nx dx can integrate करले होगे sine of nx divided by n. So this is the first part. Then minus you take, and you can again take integration, and then d dx of the first function. D dx of x is 1, so that does not exist. And then you integrate cos nx. Cos nx is again sine nx divided by n. And then you again integrate it from 0 to pi. So again you have to integrate this. So if you look here, let's put the limit here. Upper limit is pi, sine of n pi is 0. So sine of n pi 0 means everything will become 0, right? So the first term will become 0. And if you put the lower term also, again you are going to get 0. So it's 0. So that means I don't have to worry about anything here. Okay, first term becomes 0. I am having only this particular term. So if you talk about this term, integration of 0 to pi sine nx dx, this is also standard, but even if you don't use the standard function, you can still write it. Okay, sine nx के integration करले होगे minus of cos of nx divided by n. So you can put the limit 0 to pi, and then you can get this expression, right? So that means I'll get minus, this minus sign is there, so that means I've got minus 1 by n money 1 by n ta, and then I'm getting 1 minus, now cos of n pi is minus 1, so that is why I said that I've given you that list. Cos of this is minus 1 to the power n. So this is minus 1 to the power n. So I've directly put it there, divided by n, right? So there is a minus sign here. This n and n will get multiplied, n square. So it is 1 minus 1 to the power n. So an is nothing but 2 by pi. Please remember this, something which you have taken here. This is our 2 by pi. So this 2 by pi and this result. So 2 by pi shate, I put the result as this. So this pi and n square can come together. I can multiply it with 2, and then this should be minus n ke bhidor niye nilam, so it will be minus 1 to the power n minus of 1. So this is the relation that we are actually having. So you can leave it at this point as well. Also you can also write it down in the expansion form. For example, an is equal to 0 for even n. So you see this an will become 0 if n is even. That means n er value jodi 0 hoy ba 2 hoy 4 hoy, then it will be 1 minus 1, so it will become 0. So for even values it is 0, and for odd n this is going to be having some result. So for odd n money n should be equal to 2k plus 1. Okay, so odd means you can start with k as 0, so it will be 1. You take k as 1, so it will be 3. So that's why whenever we say odd, we can write it down in this way. Okay, so that means k value actually will start from 0 and it will continue 1, then 2, and so on. Okay, so value বসাতে থাকবে, you are always going to get an odd value here because this is plus 1. So that means in place of an I can write down a2k plus 1, and এখানে in place of n I can write it down as 2k plus 1. এখানেও I can write it down as 2k plus 1. So here if you write down 2k plus 1, okay, you can do the maths here. I think last time also we've done it. Divided by pi n square. So n square is it is 2k plus 1 whole square, right? And here in place of n you can write down 2k plus 1. So I can write it down as 2, and then I can take the bracket. It is minus 1, okay, and then 2k plus 1 minus 1. So you can always separate out the terms here. Okay, so minus 1 to the power 1, so that is minus 1, and minus 1 is minus 2. Okay, so you can take this like this, not minus 1 minus 2, you can separate it out. You can have a minus 1 into minus 1 to the power 2k minus 1. So this is 2k, 2 into k values are 0, 1, 2, 3, 4 and so on. So this is always going to be an even value, and minus 1 to the power even value is nothing but you are always going to get 1. Okay, minus 1 to the power 2, minus 1 to the power 4 and so on. So you are always going to get 1. So it is minus 1 into 1, which is minus 1. So it will be minus 1 into minus 1 is minus 2, minus 2 into 2 is minus 4. So this result is going to be minus 4. That's why it is put as minus 4 divided by pi 2k plus 1 whole square. So if you look into the Fourier series now, sine term to ud gaya niche ye, cos term it would be nothing but a naught by 2. A naught by 2 we have just now found out it is pi by 2. A naught by 2 is pi by 2, so we written it as pi by 2, and minus the cos term. So cos term is nothing but 4 by pi. There is a minus sign, so I'm putting minus. Okay, it was plus, so I'll put a minus because there is a minus sign here, and then cos term, right? So if you look into the original series, this is equal to the function, okay, and this will be actually given by this. So this is my a2k plus 1. Of course there is a cos, right? So if you look into the original series, there is a cos nx. So an to amra background niche, cos nx has to be there, so that's why we are putting cos nx. So what is our cos nx? Cos nx. So n is nothing but 2k plus 1 into x divided by this term 2k plus 1 whole square. This summation will be from k is equal to 0 to infinity. K is our series now. Okay, so this is how you write down. So in exams what happens is many times people may leave at this point and they will lose marks. So you cannot leave it at this point. You have to do this. This is very important. Okay, whenever it's a cos function or a sine function, you have to write it down in such a way so that you get your full marks. So that's important. Some more sums are there. The entire logic is how clear is your integration concept. Okay, the more you do integration, the better answers you'll get. So that's important. So some more sums are there. Maybe I can show you this. Okay, I don't know, it might be repeated also, I'll check. Okay, so let's check this. Okay, system is getting a bit slow. Okay, so I've used a lot of text, so maybe that's why it's getting a bit slower. Okay, so there is one more problem which is actually called the square wave problem. It says that from minus pi to 0 it is 0. Okay, if you draw the graph here, okay, I think we have drawn a similar graph in the last class as well, but if you draw a graph something like this, okay, this is 0 and 0, this is minus pi, let's say, and this is plus pi. So what happens is, if you start from minus pi and go to 0, it is not changing, it is remaining constant at 0, the function. That means this will actually represent the function. If you remember, function is nothing but y. Okay, if we recall our lower classes knowledge, y is equal to fx, so y-axis, so this is y-axis f, and it will be 0 to pi, the answer is 1, so you can take it as. So last class we have done a problem where we've taken up this is minus 1 and this one is 1. Now here it is 0 and this is 1. This makes things a bit more easy. Okay, so let's see how we can solve it. Period is 2 pi only, but we have to do it by parts. We have to take it in two parts of limit, minus pi to 0 and 0 to pi. So if I look into the function, this was our Fourier series, if you recall. Okay, and I want to find out a naught. So a naught is this 1 by pi minus pi to plus pi fx dx. Okay, so an is this and bn is this. So we have to separately find all of them, and then whatever result we get, we are going to put it in the one result. So this will be our series. So this is what we do usually. So let's find out what is a naught. So a naught ke liye we have to divide it into two parts. 1 by pi to ache, that's constant, and then we have to take it from minus pi to 0 and then from 0 to pi. So minus pi to 0, my value is 0, function is 0. Okay, we have to always keep this in mind. Minus pi to 0 it is 0 and 0 to pi it is 1. So let's check for this. So it is 0 first one, and the second one it's just 1. So that means it function to 0 ho jabe ar eta hobe plus x. So if you integrate dx is x and 0 to pi. So 0 to pi means it is pi minus 0. Protham term to already 0. So it is 1 by pi into pi minus 0, which is equal to 1. So my first term is a naught by 2. A naught we have just found out it's 1. So that means a naught by 2 is half. That's it. Calculate a naught. So it's simple. Okay. Next we have to find out an. So that is the coefficient of cosine. So that means an is equal to 1 by pi minus pi to pi 0 0 into cos nx dx plus 0 to pi 1 into cos nx dx. This is also simple. First term to 0 is second term will survive, so it will be 1 by pi 0 to pi cos nx dx. So it is just a cos term that you have to integrate. Cos nx k, if you integrate it, you are going to get it as this sine nx divided by n, 0 to pi, and then it is 1 by pi, and you take the limits here. First you take pi in place of x, so it is sine n pi divided by n minus of sine of 0 divided by n. So sine of n pi is 0, obviously we know it, right? So n pi is 0, sine of 0 is also 0. So this entire term becomes 0, an is 0. Okay. We can think about it in this way also. See, I cannot use the logic straight away using the function that it is odd or even. But if you look here, okay, if you look here also it will be difficult to use the logic of odd and even. The reason is we are not integrating it from minus pi to pi. So whether it is odd or even we don't know, because we are integrating it parts, minus pi to 0 and then 0 to pi. So if it is like that, I cannot use the logic of odd or even. Okay, otherwise I can say it's odd, it will be 0, or even it will be having some value, right? So on. But it is not minus pi to pi, it is 0 to pi. That's why we have to integrate this. We cannot straight away say it will be 0. So all cosine coefficients are 0. Okay, obviously, because end of the day it is even, but we have to keep this in mind. This is 0, this is 1. Okay, so that's why we have to do it. Okay, let's just look into the sine function now. Bn is equal to this result, and if Bn is equal to this result, again this is 0, so the second term only will survive. Okay, so it is Bn is equal to 1 by pi, integrate this minus of cos x nx by n, then 1 by pi, you take the minus here, cos of nx when cos of n pi by n plus cos of 0 divided by n. So b is equal to this n will come out, so this 1 by n pi, and cos of 0 is 1, so it will be 1, so this is the 1 here. I'm interchanging so that I'm getting this minus sign later, minus of cos n pi. But what is cos n pi? Minus 1 to the power n. We have already seen that. So if n is even, okay, if n is even, cos of n pi is 1, okay, because this power will be even, so this will be minus 1 to the power even power, so this will be 1. So if this becomes 1, this becomes 0. So if n is even, this term will become 0, it will vanish. Okay, so we are just left out with a0 by 2, which is equal to half if it is an even function. Okay, if n is even. Okay, but if n is odd, on the other hand, okay, this analysis is very important. Fourier series, cos n pi, it is minus 1 odd only, so that means this bn will become 2 divided by n pi. So that means I can write down 2, one for odd and one for even. Okay, so we can take this as odd, and odd means n can be taken as 2k minus 1. Okay, k can start from 1, 2, 3 and so on, because we're talking about here is not starting with 0. Okay, uh, so we can start with 1, 2, 3 and so on. So we can write down this bn as 2 divided by 2k minus 1 into pi. Okay, so that's important. So this will be the value of bn if n is even. So the final Fourier series will be this plus this plus this. The cosine term a0 by 2 will become half. Okay, and the sine term survives. The cosine term becomes 0. This is something which we have seen. This is 0. Okay, this is 0. So only this term survives. This term is bn, so bn is 2 divided by 2k minus 1 into pi, so 2 divided by 2k minus 1 into pi into sine of nx. But what was our n? N is 2k minus 1, so I've replaced n as 2k minus 1 into x. So this is our series. Okay, this is our Fourier series, and we want to write it more explicitly, means I want to expand it. So if I want to expand it, first term would be half, second term k starts from 1 here. Okay, we're starting with 1. Okay, and if I start with 1, then I can write down this as 1. So this is 2 divided by 2 into 1, 2 minus 1, so it is 2, and this 2 can be taken out. Okay, because k is fixed, so we're taking only k values into pi. Okay, so this pi is also taken out, so this 2 by pi is actually taken out, and remaining I can expand. So 2k minus 1, k value to them 1 near, it will be 2 into 1 2 minus 1, it is just 2, and then here also it will be just 2 into 1 2 minus 1 is 1, so it is x sine x. So that means the first term is sine x. Then I can again take the k value as 2, so it is 2 into 2 4 minus 1 is 3, so here comes 3. Okay, and then sine of 3x, so sine of 3x, then sine of 5x divided by 5 and so on. So I can expand it, but here it's not that if you leave it here you're going to lose marks. No, you can leave it here, or you can expand it as well in this way, so that is also possible. As it says, it's a series, so it's going to be one term after the other and so on. So Fourier series, that's why how it works. This is going to work in any other series that we discuss, maybe Taylor series, Lorentz series, power series and so on. Everywhere we are going to expand it in a similar fashion. Final result, put the values, and then you're going to get the result. So that's very important. Sometimes you can have these kind of questions as well, where the limits are not pi to minus pi, or L to minus L, or to plus L, or minus pi to plus pi. That is also possible. So for such functions, let's see, it may be slightly different. Here also we are basically having a periodic function where it is from 0 to minus 1, the answer is always 0, function is always 0, and from 0 to 1 the function is 2. Okay, you can draw it also, and the period is 2 here, because it's from minus 1 to plus 1, total length is 2, so that's why the period is 2 and not 2 pi. Okay, So if I want to do these kind of problems, what I have to do is first I have to tackle the limits or tackle the value of L, because original formula it was cos of n pi x divided by L. Okay, if you look here, कहाँ गया? Yeah, if you look here, okay, we know that it is pi function. Okay, so the formula is this. Okay, but if you try to recall the original formula, it was n pi x divided by L, but our L here is pi, so that means it will be n pi x divided by pi, so that pi gets cancelled, so it becomes cos n x. Okay, so it is always better to remember it in terms of the original formula. Okay, and the original formula is this. Original formula is this: an cos of n pi x divided by L. But let's see what is our L here. Our L is 1 here. This is 1. Okay, this is minus 1. So L is 1. So I'll just put the value as 1 and the L as 1. So it will be cos of n pi x bn sine of n pi x. So there is an additional pi which comes in here if it is minus 1 to 1. So you remember the original formula and then corresponding value of the limit you put, and then you will know. Minus pi to pi hole L value pi ho jabe, so pi will be getting cancelled, it will be cos n x. But it is minus 1 to plus 1, so L की value हो गई 1, and then you get this function. Okay, now I have to do my integration. So for a naught it would be 1 by L minus L to plus L fx dx, but it is not L anymore, it is minus 1, so I'll write it down as minus 1 to plus 1 fx dx. So please remember this, L you have to replace here. Original formula में it was 1 by L. Okay, if it is pi it will be 1 by pi if the limit is pi, if the limit is L it will be 1 by L, right? But here L value is 1, so I'm just putting 1, so 1 by 1 is 1, so that means this is the one, so it becomes more simplified rather. And then it is 1 by L, again it will become just 1, and then fx की जगह fx, and then cos of n pi x, cos of n pi x dx. So this is the integration. So these are the coefficients that we have to calculate. Okay, and then we can easily find out our answer. So here also the same thing, put the values. पहले वाला तो 0 है, दूसरे वाला 0 to 1 में तो function is 2. So this, find it out, limit 0 to 1, answer is 2. So that means if it is 2, that means a naught by 2 is equal to 2 by 2, because a naught की value तो 2 मिली है, 2 by 2 1 हो गया, तो this is 1. So this becomes in fact simple. Second coefficient is an, so the first part is 0, becomes 0. Second part is 2 into cos of n pi x dx, so which is equal to 2, बाहर ले लिया, integrate this, so it is sine of n pi x divided by n pi, 0 to 1. So you will take 2 by n pi, 2 pi n pi बाहर ले लिया, अपर लिमिट बिठाया 1 है x का वैल्यू, तो it will be sine of n pi minus sine of 0. But what is sine of n pi? 0. Sine of 0, 0. So it is 0. The end of the day, an is becoming 0. Next, let's take bn. Bn also in similar way. First term will become 0. Second term would be this. Okay. Second term would be this. And then you can take out 2. And then minus of cos of n pi x divided by n pi 0 to 1. यहाँ पे थोड़ा करना पड़ेगा. It is minus 2 by n pi. You can take it out. Cos of n pi minus cos of 0. Put the limits. Minus of 2 by n pi. So cos of n pi is minus 1 to the power n. Minus 1. So it is 2 divided by n pi. You interchange it. You take it here. You bring it here. Minus sign goes in. So it is 1 minus 1 to the power n. Again the same thing. If n is even, then this will be 1. 1 minus 1 is 0. So this entire term will become 0. If n is odd, it will be 2 divided by n pi. So this will be 4 divided by n pi. Same calculation as before. If n is odd, you can take it as 2k plus 1, and then you can do a calculation. You're going to get 4 divided by n pi. So that means this is my final series. I have got the first term and the sine term. That's it. So it is 1 plus 4 by bahar hai already. So you can take this as k की value. You can start from k is equal to 1 to infinity. Keep on writing. You get this result. So this is again an interesting problem. Okay. Okay. यहाँ थोड़ा different है. Okay. You can check this. If you check here, sine x is the function if it is 0 to pi.
So screen टा कैसे बोल?
चलेगा सर सीधा. Network issue maybe. Okay. So this is actually called a half wave rectifier problem, but end of the day, all problems are similar. You have to just do the integration correctly, use the logic correctly, that's it. So what I feel is the most important thing is remembering the series in terms of L, and then finding out the coefficient based on that. Okay, so that is what is going to help. So I've taken one more odd problem here. The problem is that the function is sine x if it is between 0 and pi, and the function is 0 if it is between pi and 2 pi. Okay, so there is this overlap here. Okay, pi and 2 pi between it will be 0, but if it is 0 to pi it will become sine x, so there is an overlap. So here let's say we have to calculate a naught. So a naught is 1 by pi integration of fx dx. Our limit goes from 0 to 2 pi total. Part by part we have to write down. First we have to write down from 0 to pi sine x dx, and then we have to write down pi to 2 pi. So pi to 2 pi to 0, so second term 0. The first term is sine x dx, so it will be 1 by pi minus cos of x pi by 0. So minus cos of pi plus cos of 0, put the limit. Cos of pi is minus 1, so minus 1 will become plus 1, so 1 plus 1 is 2, so it is 2 divided by pi. So that is the value of a naught, but a naught is a naught by 2. First term is a naught by 2, so a naught by 2, a naught इतना है बेच के तो 2 by pi, so answer is 1 by pi. So this is the a naught value. Let's find out an value now. An value is 1 by pi 0 to 2 pi fx cos nx dx, right? Here also we'll separate it out. Second term को separate करने का कोई मतलब नहीं है, because second term is always 0, so you have to integrate always from 0 to pi, so thing becomes easy, right? So this becomes 1 to pi 0 to pi sine x cos nx dx. Now this is a bit tricky because it's a multiplication of two trigonometric function. If it is a multiplication of two trigonometric function and you want to use the product rule, you are never going to arrive at a result, because it's always ddx of sine x will again give you a cos x, and again it will become sine x, so it will keep on changing. It's not going to reduce. It is none of the factor is reducible, so we are going to use this identity of sine a cos b. So sine a cos b is half of sine a plus b plus sine of a minus b, already seen the list, so I can write it down in this way. Okay, what is our a? A is x and b is nx. Okay, so we can take x plus nx. X can be taken common, so it will be 1 plus n, so 1 plus n x common, 1 minus n x common, so you can rewrite it like this, and then you integrate it. So, okay, this is a simple thing that you have to remember, otherwise exam may you will get puzzled, because it's both a trigonometric function. We'll expand it and we will solve it. So I've expanded this and then I can solve it. Okay, so it is 1 divided by 2 pi, and just do it, sine of 1 plus nx, so you can do this, cos of 1 plus nx divided by 1 plus n, and then this, put the limits, and this is something which you are getting. So this is my final result here. So here I can check, okay, these things are not needed right now, okay, but anyway you can understand this. Okay, it's not very complicated. So we can simplify this, this what, 1 by 1 plus n plus 1 by 1 minus n, simplify it, it will be 2 divided by 1 minus n square. Okay, and then we can take this cos of 1 plus n pi, cos of 1 plus minus n pi can be written as cos of pi plus n pi, so it will be cos of a plus b, you can write it down as cos a cos b plus minus sine a sine b. Okay, minus plus sine a sine b. So if it is cos of a plus b, it is cos a cos b minus sine a sine b. If it is cos of a minus b, the formula is cos a cos b minus sine a sine b. So cos pi is minus 1, okay, cos of n pi is minus 1 to the power n, and sine of pi is 0, so the second term will become 0. I am only left out with this, so this will be minus 1 to the power n. So this is one thing that we can use here in this result. And then another result is something like this that we need, okay, minus of cos of this. So this again you can do the same thing, you will get minus 1 to the power n, because ये वाला term तो minus 1 to the power n ही है, so you can take it. Simplify this and that, replace it, simplify this. You definitely, I can explain it, but you have to practice it, that's very important. So this is your an. So this is my an, and then we have found out a naught. Okay, an we can further play around with, like if n is odd, you can check here. If you simplify this, you get this as an, and if n is odd, okay, n is greater than 0, then minus 1 to the power n will be minus 1, so this will become minus 1, so this entire term will become 0, so an will become 0. If n is even, then you will get an is equal to 2 divided by pi into 1 minus n square. You can take n even when n is equal to 2k plus 1. Okay, you can start with this, n is equal to 2k, just like before we have done. K plus 1, just like before. You can use it and then you'll get this. Okay, so the original formula will become this. So this is important. We can leave it at this point as well. Okay, or we can calculate a1, because if we take n is equal to 1, n is even, it's fine, we can get this result. But if n becomes 1, this will become 2 divided by 0, so this is not possible. So for a1 we have to compute it separately. A1 can be written as 1 divided by pi. A1 mane n er jagah pi, n er jagah 1, that's it. Okay, so if you look here, an, so an in place of n you're going to put 1, so it will be sine x cos x dx. Okay, so this is can be computed separately. So this is a bit complicated problem, I know. So cos x you do it, integration, you're going to get 0. So that means for n is equal to 1 it is not going to exist. It can only exist for greater than 1, and that is why it is written greater than 1. Okay, so this will exist. Then you take bn may have to take the sine series. So this is again the integration. Again the same thing, both are non-reducible, so I cannot use the product rule. I have to expand it, cos a minus b minus cos of a plus b, expand it and do it. Okay, so for n not equal to 1, you can take the value of bn is again which is equal to 0. Okay, you can check this. Okay, anyway I'm not doing it, it's very simple. You have to just practice it, that's more important. Then b1 के अलग से लेना है, and b1 को अगर अलग से लोगे is going to be half, so that's important. So final series for n is equal to 2k even terms. You cannot take 1, this n value cannot be 1, so 2k plus 1 we cannot take. We can just take 2k even terms, where k starts from 1, 2, 3 and so on. So it will be, any value would be 2, 3, 4, because n is equal to 1 it is anywhere not valid. So n is equal to 2. Let's start with n is equal to 2. So with n is equal to 2, it will be 1 by pi plus half sine x. Okay, so that's the value that we have got here. Sine term ka coefficient b ka, so it is half, minus 2 by pi cos of 2kx divided by 4k square minus 1. So this is a bit complicated, because you have to analyze whether it is valid for odd, even or not. If it is not, then you have to analyze it further. But many a times what happens is, depends on the marks. If you leave it with the result without analyzing whether what will happen at even or odd points, you'll still get some marks. Okay, sometimes they might not get, but most of the times they might consider this as well. Okay, this one I think you can practice. I'll probably share this with you, but I think you can practice it once. Okay, this is also simple. It's like a Fourier series. Fx is equal to x plus 1 and the interval is 0 to 2. So please remember, period is 2l is equal to 2, so l is equal to 1. Okay, so here also you can consider the value of l equal to 1. So that this would be the integration. In place of fx you have to write down x plus 1. So in place of fx you put x plus 1. Okay, so your function you can separate it out as well. You can directly put fx is equal to x plus 1, you can get the result, or you can take the function, because it's symmetric. Okay, so if you have a periodic function with period 2, the interval minus 1 and 1 is also one period. So you can take it either from 0 to 2, you can take it either from 0 to 2, or you can go from minus 1 to 0 and then 0 to 1. So that is also having a period of 2. Okay, so then you have to do it accordingly. So this is also slightly different. It's not do this, but I hope up to this point it's clear.